Solving systems by graphing really is not an exact way to do it. It's not a very good way. Like I said and demonstrated, you have to be really good at graphing. You have to have really good lines when you do it to be able to do it accurately and do it well. What we're going to do the rest of this time is solve them algebraically. The first way is solving by substitution. Now, how many variables do I have in a system? I have 2 variables in the system. So how many answers do I need? I'm going to need 2 answers. So I have x and I have y. I need to figure out what x is. I need to figure out y is. I always have 2 answers whenever I do this. Okay. So the first example, right up on top, if y equals 4 and x plus y equals 10, what is x? This is a simple problem to solve from a substitution standpoint. I already have one answer. There's one answer. One of my answers, y equals 4. Now I got to figure out what x is to go with it. And this is where substitution comes in. And this is as simple as substitution gets us on this first problem. Because y equals a particular numeric value. I know what y is. I take this y here and replace it with 4. What's y? Y is 4. So I take y and I replace it with 4. And then I solve that equation for x. This one's easy. Subtract 4 from both sides. And I get x equals 6. Okay. Now, let me make this statement first. Because many of you figured out what the answer was without doing any work. Because if you have 2 numbers that add up to 10 and one of them is 4, what does the other one have to be? It has to be 6. I get that. I understand that. I really, really hope that if you say, ooh, I have 2 numbers and I add them, I get 10, and one of them is 4, what's the other one? It's 6. That you can figure that out without having to do the algebra of solving the equations. I hope you can do that. That's not the point of some of these simpler problems. The point is you still do the work because you get used to doing the work. Because it will get more complicated as we go along. Okay? I hope you can figure out what the answers are. But once again, it's, I want you to show the steps to do it. This second example is a little bit more difficult. Okay? I have a system of equations. I have 2 equations and I have 2 variables. I want to solve for those 2 variables. I want to figure out what x is. I want to figure out what y is. Now, when I do substitution, just like I did in the first one, it's really, really, really nice if one of my equations already has y by itself or has x by itself, like I have in this first one. I know what y is. What is y? Y is 3x. Okay, y is 3x. I don't know what x is yet, so I don't know the singular numerical value, but I do know what y is. It's 3x. So I go to the second equation. I go, hey, I have y here. I take that y and replace it with 3x. Only the y gets replaced. Everything else stays the same. So I have x plus 3x equals negative 32. I took the y, replaced it with what y is. Y is 3x. I now have one equation and one variable. I can solve that one equation per variable. I can solve this for x. First step, combine up like terms. I have 1x and 3x. It means I have 4x's. 4x equals negative 32. Divide both sides by 4. And x equals negative 8. How many answers did I say I needed to have? 2. I have 2 variables. I have x and I have y. I know what x is. X is what? X is negative 8. Now I need to figure out what y is. And I do the same thing I basically did in the first problem. Is, ooh, x is negative 8. I put negative 8 into here. X is negative 8. I take the x in this one and replace it with negative 8. Y equals 3. times negative 8, because y equals 3 times x. I put negative 8 in for x. Y equals negative 24. Okay. Yes? 1x plus 3x is 4x. I have 1 apple and 3 apples. How many apples do I have? 1 and 3 make 5? Oh, 4. And do not be offended that I used apples, because I did that same thing with my Algebra 2 class this morning. You have so many of this and so many of that, and combine them together, how many do you have? Okay. So I have 1 apple, I have 3 apples, I have 1x, I have 3x, how many x? I got 4. What do you get them on? We don't make fruit salad in here. Sorry. Okay. So the second one. Oh, it's not pretty. The first two problems, I had y equals something. I had y by itself. To do substitution, you need to have either y by itself or you need to have x by itself to do substitution. I don't have y or x by itself. So what I need to do is take one of those two equations and rearrange it to get y or x by itself. And I can do either one of them, but I can tell you which one's going to be the easy one. The second one. It's going to be the easy one to rearrange. So I actually have several steps to this problem. My first step is to rearrange this to solve for x or solve for y. So my first step here, add 2x to both sides, which means that I have 2y equals 2x minus 6. Does the 2x and negative 2x cancel? I can't combine 2x and negative 6 together, right? Because they're not like terms. One has x's, one doesn't. Okay. And now I get down to here, I need to get y by itself. So if I want it 1y, I don't want 2y, I want 1y, what do? I divide by 2. If I divide that by 2, I divide everything by 2. And I get y equals x minus 3. I have to get y equals or x equals first. If I don't have one equation that has that, I have to do that. That's my first step I did here. Rearranged it to get y equals. Now I know what y is. What is y? Y is x minus 3. Now, I have to do the substitutions that I just did before. Same idea. But there's one thing you cannot do. I cannot substitute this into the equation I rearranged. I need to substitute it into the other equation. I need to take this x minus 3 and put it in for y. So I now have 3 times whatever y is plus 4x equal to 12. And then what do we figure out y was? Y is x minus 3. So I have 3 times x minus 3. That's my substitution. And now I need to solve. We've done this before. It's been a while, but we've done these problems just like this before. My first step, distribute. Get rid of the parentheses. So I do 3 times x, 3 times negative 3, and then I still have my plus 4x that I haven't done anything with, equals 12. Combine up like terms. How many x's do I have? I have 3 here, and I have 4 there. 3 plus 4 is 7. So I have 7x minus 9 is equal to 12. Add 9 to both sides. 7x is equal to 21. Divide by 7. X equals 3. So I have how many answers? I have 1 of my 2 answers, yes.
I was going to ask, what happened to the plus 2x below the negative?
This one here?
Yeah.
We're ignoring it at this point. Okay, let me be clear. I used this equation to get this equation. That's what I did there. Once I get y equals, I needed to take this part that I found here, this equation that I did. I just took this one and rearranged it to get that. This is the same equation, just rearranged. Okay, that's what we did. We just took this equation, rearranged it to get y by itself. That lets me do a substitution. If I don't have y equals, or if I don't have x equals, I can't do a substitution. So that's what I did first, was I rearranged it so I can do my substitution. Then I use this in here for y, and that's what all this stuff over there is. Does that make sense? Okay. So how many variables do I solve for? I solve for 1. I know what x is. X is 3. What do I need? I need 2. I still don't know what y equals. Y equals x minus 3, but that's not a singular value, right? What I can do is now I take this that I got down here, I take this value of x that I got here, and I can put it into this equation, or this equation, or that equation. It doesn't matter which one. I can stick x in for x into any one of those equations, and there's one that's obviously easier than the rest. The one down here. Do what's easy, or don't. I know, because you're going to say, well, easy is not doing anything at all. Yeah. Do the easiest problem you can, but you still have to work the problem. So yeah, down here this is the easy one. Y equals x is 3. Put 3 in for x. 3 minus 3, so y equals 0. There's my answer. X is 3, y is 0. There's my 2 answers. Okay. Questions so far? I'm sure it's mostly confusion at this point, but are there any questions? Okay. So, word problem. These are typical word problems. Systems of equations really like word problems. They love word problems, and they're often very easy word problems to do. You have 2 variables, 2 equations. That's what you need to have.
Oh my God, Russell.
I guess he wins the lottery and gets to leave early. Okay. So read the question. A snack bar sells 2 sizes of snack packs. A large is 5, a small is 3. In one day, the snack bar sold 60 snack packs for a total of $220. How many snack packs of each did they sell? Okay, the snack bar is going to go out of business. They can't keep better records than that, and have to use algebra to figure out what they sold. These are stupid questions. Because if you're running a snack bar and you can't keep track of what you sold and need to do algebra to figure out how many of each you sold, then you're going to go out of business. But we still have to solve the problem anyways. It's really quite easy. There are 2 equations. One for how much, one for how many. One for the dollar value, one for how many you sold. So I have to have my 2 items. My large snack pack and my small snack pack. L and S. Large, L for large, S for small, right? Okay, how many did I sell altogether? How many were sold altogether? I sold 60. So that means the number of large plus the number of small is 60. There's one equation. There's my equation for how many items I sold. I sold 60 items. I sold so many large. I sold so many small. I don't know which, so it's L and S. The number of large plus the number of smalls equals 60. There's one equation. My second equation is a little harder, but it's not that difficult. It's how much money you get.
I don't even know they sold 8.
They sold, they didn't, we don't know they sold 8. It's an S.
So where did the 8 come
It's an S.
It's the S, right?
It's not written as a 2. I put a line on it so it doesn't look like a 2.
Oh, it's
Or 5, sorry. Okay. So, the other one is how much it's worth. The large one sold for $5 each.
Would that be this class?
What's up, Roman?
One half bit one.
I'll have it.
No, I don't want to have a bit more.
Thank you.
I want it.
I'm gonna go before I get in trouble.
Next time, remember me.
I promise. I
Okay, so large ones sell for $5. So 5 times the number of large ones is how much money I made off the large ones. Okay, guys, no. Okay, 5 times the number of large ones. Okay, is how much money you had spent on large. How much money you made off the large ones. $5 per large. $3 for each small one. $3 for each small one. And how much money did I make altogether? $220. Okay? That's what you do. That's your setup. The number of large plus the number of small equals how many you sold altogether. How much you made off the large, the price per large one plus the price per small one adds up to how much money you make altogether. Now you need to solve the system and figure out how many of each. Okay. First thing you have to do is you have to get L or S by itself. I'm actually going to subtract S from both sides. So I get the number of large is 60 minus the number of small. Now I have large equals 60 minus S. I take this, put it in there. Everything else stays the same. I'm just replacing L. So I have 5 times 60 minus S plus 3S equals 220. Now I have to solve for the number of small, then I can figure out the number of large after that. Distribute to 5. 5 times 60 is 300. 5 times negative S is negative 5S. See why I put the line on it? So I can tell the difference between my 5s and my S's? Yeah, you're not as close as I am. Plus 3S equals 220. Distribute, combine like terms. Negative 5S plus 3S. Negative 5 plus 3 is negative 2. 300 minus 2S equals 220. Now it's 2 steps. This is a 2-step equation from here. Subtract 300. I get negative 2S is equal to negative 80. Divide by negative 2. And the number of smalls is 40. They sold 40 smalls. How many large do they sell? Yeah. Go back to here. Put in 40 for S on this one. The number of large is equal to 60 minus 40. The number of large is 20. Like I said, this is not the most efficient way to figure this problem out. They should have kept better records to begin with. I mean, you're selling something, you should go, oh, I sold a large, I sold a large, sold a large, sold a small, sold a small. Just keep better records, then you know how many of each you sold rather than having to do this crap. Because if you leave it to the end of the day and have to do this, you're going to go out of business. You should keep better records than that. Okay, so we have here two particular types of problems. Okay, these are goofy ones. Now the substitution's already set up. I already have x equals my first set of problems and y equals my second set of problems. My first one, x, is negative 2y plus 4. So I put negative 2y plus 4 in here. So I have 3.5 times negative 2y plus 4 plus 7y equals 14. Distribute. 3.5 times negative 2 is negative 7y. 3.5 times 4 is 14. Plus 14 plus 7y equals 14. Combine up like terms. I have negative 7y and positive 7y. What's negative 7y plus 7y? What's 0? So how many y's do I have? I have 0 y's. These cancel out, and I get 14 equals 14. Okay, first odd situation. This is an odd one. What happened to my variables? They're gone. They all dropped out. Is that a true statement? Yeah, 14 equals 14. If this is a true statement, then I have an infinite number of solutions. If your variables drop out, if your variables disappear while you're solving, and you get a true statement, 14 equals 14, then you have an infinite number of solutions. Yes? What, here? Here. This one's kind of a mess because I have negative 7y and positive 7y, and what did I do? Yeah, I canceled these cancel each other out. 8 next to what 4? H? No, that's plus 14. So if my variables disappear and I have a true statement, everything works. Remember when we were talking about the graphing and you had two lines that are exactly the same line, one on top of each other? That's exactly what's happening here. These two equations are versions of each other. It's the same line. If you graph the top one, graph the bottom one, you get the same line. There's an infinite number of solutions. So this one's kind of the same thing going on here. Y equals 3x minus 11. So what I do is I put 3x minus 11 in for y. I take the y, replace it with 3x minus 11. 3x minus 11 minus 3x equals negative 13. 3x minus 3x, how many x's do I have? How many x's do I have here? I have 3 here, negative 3 here. What happens to my x's? They cancel each other out. They're gone. Boom. Boom. So I'm left with negative 11 equals negative 13. Is this a true statement? Does negative 11 equal negative 13? This is not a true statement. This is a false statement, which means that I have no solution. Those two lines do not cross each other anywhere. Usually what happens when you're solving these problems is you get an answer. You get x is some number, you get y equals some number. 90% of the time, that's what happens. Once in a while, you get one of these too. If it's true statement when you're done, everything works. If it's a false statement when you get done, nothing works. Okay, and you're going to have a couple of these on your homework tonight. For class one. Yes, you can. I just write this with infinite, right? I just don't write the many solutions. I just write the infinite. Okay. Questions?